Hello everyone, I'm Paul and today we're solving problem 2654, minimum number of operations to make all array elements equal to 1. This is a medium math problem, so let's start. We are given an integer array nums with only positive integers, so let's say that we're given this. Our job is to transform every element to 1 using this operation any number of times, and the operation goes as follows. We can take any two adjacent elements and get the corresponding GCD of these two elements. Now, this means greatest common divisor or greatest common factor. The corresponding factors of number 2 are 1 and 2. If we do 2 divided by 1, the remainder is 0. And the same goes for 2 divided by 2. Now, the factors for number 6 are 1, 2, and 3. So the greatest common factor between these two is 2. And once we get this, we can replace any of these numbers with the corresponding GCD. Let's say we replace this with 2. And this is actually not very smart because we need to return the minimum number of operations to make all elements equal to 1. So actually, we should look for a number 1 in this array. And if we don't have a number 1, such as in this case, we should look for two adjacent elements with the GCD equal to 1. Let's see what I mean. Let's say we take these two adjacent elements. The factors of number 3 are 1 and 3, and the factors of 4 are 1, 2, and 4. So the GCD of these two numbers is 1. Let's say we replace this with 1. Here we have one operation, so the result right now is 1. Now the greatest common factor of 1 and another positive number is always 1. So GCD of 3 and 1 is 1. So we can replace 3 with 1. And here we are using another operation. This is 2. So now you can see how we can use another operation for these two elements to transform these to 1. So this is 3. And we use another operation for these two. Now this is 1. This is 4. And this is the minimum number of operations. So we return 4. Now let's say that we start with this array. Here it's much easier because we already have a 1. So the result is initially 0. We can use one operation for these two. This is now 1. This is 1. 1 for these two. This is 1. This is 2. And 1 for these two. So this is 1 and this is 3. So if we have a 1, we can just use this 1 to get the corresponding result. Now, if we have 3 1s, for example, here we can use only one operation, so the result is 1. Now, there's a very easy way to get this, which is we can get the total amount of elements, meaning 4, and subtract the amount of 1s, meaning 3. And that's how we get the result. So for the first case, if we have one number 1 or more, this is very easy to solve. Now, if the overall GCD of this entire thing is greater than 1, this means that we will never be able to find the solution. And remember that in this example, these are the two elements that enable us to solve this. If we didn't have these two elements and we take the GCD of 2 and 6, the result is 2. 2 is greater than 1. And what this means is we will never be able to get to number 1. Okay? So if the overall GCD of the entire array is greater than 1, we return -1. It's right here in the description. And we have one more case, which is we don't have any 1, but the overall GCD of the entire array is 1. And that's this case. Here we have two ways to get a GCD of 1. We can take these 3 elements or these 2. If we take these 3, we take the GCD of 2 and 6, which is 2, so we replace this with 2, and the GCD of 2 and 3 is 1, so we could replace this with 1. And here we are using 2 operations. Now, if we take these 2 elements instead, the GCD of these 2 is 1, so we can replace this with 1. Here we get a 1 in 1 operation, and here we get 1 in 2 operations. So this is more efficient, and actually we are looking for the smallest subarray with a GCD equal to 1. That's why this is more efficient, because this subarray has only 2 elements and this one has 3 elements, okay? So in this third case, we find the smallest subarray with a GCD of 1. So here we know that the smallest subarray has a length of 2, and we need to subtract 1, and this is the amount of operations that we will use for this subarray. We will use only 1 operation, because here we have 2 elements, we need 2 elements per operation, so we always subtract 1. If this was the smallest subarray, we would take these 3 elements minus 1, meaning we need 2 operations here, 1 for these 2 and another 1 for these 2, okay? So here we need 2 minus 1 operations, meaning 1, to get a number 1. So after this, we have a 1 here. And now we need n minus 1 operations, here n is 4, and we subtract 1 for the 1 that we already have. So here we need to add n minus 1, 4 minus 1 operations. And this is 3 plus 1, 4. So in this case, we return 4. And just to be clear, what we are doing here is we take the minimum length minus 1, and this will give us the total amount of operations to get the first one. And then we need to add the total amount of elements, meaning n, minus 1 for the one that we already have, okay? We need to subtract this from the total amount of elements. So this is the final formula to get the result for case number 3. So this is the entire approach, and now with this in mind, let's go with the code. We already have a Python method to get the corresponding GCD of 2 numbers, but I will show you how this works just in case. Let's say we have a function, this takes 2 numbers, and if a modulo b is equal to 0, we can just return b, else we return GCD and swap places. Here we say b modulo a and a, okay? Remember, as I said before, this is not necessary. We already have a Python method for this. Now, n is the length of nums, and the initial amount of ones is 0, and the GCD for the entire array is initially 0. Now for every number in nums, g is GCD of g and x, and we say if the current number is a 1, we add 1 to ones, so ones plus equal 1. Now once we have this, we can say if GCD of the entire array is greater than 1, we are ready to return minus 1, because we will never be able to get an array with all ones. Now, if the amount of ones is greater than 0, we are ready to return n minus ones. We are using these ones to transform every other element to 0, okay? Now for the third case, this is case 3, here we have no ones, but GCD is 1. In this case, we need to get the minimum length of a subarray with the GCD of 1. So this is initially n, which is the maximum value. And just to be clear, sorry, here we will get the minimum length of subarray with GCD equal to 1. And now we are ready to iterate every subarray. So for this, we can use a nested for loop. We say for I in range n, for j in range from I to n. And we start always with a GCD of 0. And we need to update this every time. So here we say GCD of g and nums j. Sorry, nums j. Now, if at any point the corresponding GCD is 1, we say minimum length is the minimum of minimum length and the amount of elements in the current subarray, meaning j minus I plus 1. And if we find this, we are ready to break this inner loop and continue with the next I. Okay, so finally we can return our small formula, which is the minimum length minus 1 plus the total amount of elements minus 1 for the one that we get after doing this. Okay, so this is the entire code. Let's submit this and see if it works. Here I'm misspelling minimum length, so let's fix this and try again. As you can see, this works and it's very efficient. Here time complexity will be big O of n squared times log of the maximum number if in nums. That's the overall time complexity of this GCD function. Okay, and space complexity will be big O of 1. So that's it for this problem. If you found this useful, please drop a like, subscribe, and see you in the next one. Bye bye.